What are isotopes, and how do they vary in elements? Have you ever wondered why some elements can exist in different forms? Let's take a closer look at isotopes and how they vary within elements. Isotopes are unique versions of the same chemical element. They share the same number of protons in their atomic nuclei, which defines what element they are. However, they differ in the number of neutrons they contain. This difference in neutron count leads to variations in mass numbers, while their chemical properties remains nearly identical. To visualize this, think of an atom as a tiny structure. At its center is a dense nucleus made of protons and neutrons, surrounded by electrons. The number of protons, known as the atomic number, determines the element. For instance, carbon always has 6 protons, while hydrogen has 1. The number of neutrons can change among atoms of the same element, resulting in isotopes. Take hydrogen as an example. It has 3 naturally occurring isotopes: hydrogen 1, which has no neutrons, hydrogen 2, which has 1 neutron and is also called deuterium, and hydrogen 3, which has 2 neutrons and is known as tritium. Despite these differences in neutrons, all these isotopes behave chemically like hydrogen because they have the same number of protons and electrons. The variation in the number of neutrons affects the atomic mass of the isotopes. For example, carbon-12 has 6 neutrons, while carbon-14 has 8 neutrons. This makes carbon-14 heavier and radioactive. Radioactivity means that carbon-14 decays over time, which is a property used in carbon dating to determine the age of ancient objects. In contrast, stable isotopes do not undergo such decay. Isotopes have many practical applications in our daily lives and in various fields of science. In medicine, radioactive isotopes are used for diagnosis and treatment, such as in cancer therapy or imaging. Environmental scientists and geologists use isotopes to trace processes like climate change or to determine the age of rocks. In industry, isotopes play a role in oil and gas exploration and in national security for detecting materials. In essence, isotopes are like different family members of an element. They share the same core identity, which is the number of protons, but differ slightly in weight due to the number of neutrons. This small difference can influence physical properties and stability without changing how the element behaves chemically. Understanding isotopes opens up a fascinating view of the natural world and their usefulness in various fields.